In this video we're going to be looking deeper into differentiation and why we have to differentiate. Differentiation is, put simply, a way of finding the gradient of a graph at a certain point. And the gradient is how much the graph changes for every 1 unit moved to the right. So that's the steepness of the graph. I want to show you a few examples to do with this. So I've got some graphs here, and in this first set we've got gradients that move. So for every 1 step we move to the right, we move 2 up. So the gradient is the change in y divided by the change in x. So the gradient of that line there is going to be 2, because it's 2 over 1. Here, for every 1 across, we're going down 1. So that's going to be the change in y, which is minus 1, over change in x. So the gradient of this one is minus 1. And then finally this one, I'm always taking it from where there's a full coordinate where the 2 grid lines intersect, because that makes it easier to work out. And from there it goes down 3 and across 1. So it's minus 3 over 1, which means the gradient here is minus 3. Sometimes it won't be whole number answers like we've got in these examples. Sometimes it'll be different. So here we've got, it goes across 2 and then up 1. So the change in y is 1 and the change in x is 2. So in this case it's a fractional gradient. I'm going to get the same in this scenario here. So we've got, it goes across 4 and then up 3. So if you know, I didn't go there because that's not at a grid line, neither is that one or that one. I went to the nearest next grid line from where I started. So it's 4 across and 3 up, which means it's the change in y over the change in x, 3/4. And here, same deal. I'm going to start at this grid line here, and then I'm going to find the next one, which is down there. So it's down 5 and across 2. So it's minus 5 over 2. So that's our gradient, minus 5 over 2. Change in y over the change in x. So we know what finding the gradient is for straight lines, but differentiation is to help us working with curves. So if I look at some curves here, they're not on any grid lines, so we're not going to be able to measure the gradient, but it's just an idea to get the concept here. For each of these lines, we're not really able to tell what the gradient is just by saying the gradient of that curve is something, because the gradient at each point changes. So if I wanted to know the gradient at this point, it's going to be different to, say, the gradient at this point. And also, how do I tell the difference? So if I wanted to say the gradient of this line, do I measure the gradient between those 2 points, or would I measure the gradient between those 2 points? What are the points that I measure between? The idea is actually that we're taking a tangent at each point. So we'd have a gradient for each point on the line. So if I was to rub all of this out and show, let's say I want to know the gradient at this point, or say at this point, I'd have to draw a tangent at each point. So a tangent is a line that just touches the curve at a specific point, and that'll tell us the gradient of the curve. Can we see how the gradient here is steeper here, then less steep, and even less steep? So the gradient changes in the curve as we move along it in this example. So because the gradient keeps varying, rather than just having a number, which is what we had for the previous ones, which were just lines, what we're going to end up with actually is we have a function. So it could be something like 2x plus 4. That could be our function. And then whatever the value on the x-axis, so let's say the value here was 2, then our function would be 2 times 2, which is 4, plus 8, which would be 12. So that would be the gradient at when x is 2. So we're using that function to tell us whatever the gradient is at a specific point on the graph, because the gradient changes as we move along the graph. So the gradient here is going to be different to the gradient here. So that's why we need a function rather than just a single number. Let's have a look at how that works on an actual graph. So here I've got an x squared graph, and let's say I wanted to know the gradient at some points. Let's say I wanted to know the gradient at 1 at this point here. Let's say I wanted to know it at this point here. I'm going to draw in a tangent to both of those, and we'll work out the gradients. So I've drawn in these tangents. I've drawn the one in at where x is -2 here, and it's this red one. So if I measure the gradient of this one, you can see it crosses a coordinate there, and then it crosses again here. So it goes down 4 and across 1. So the gradient at -2 is -4. So at that specific point, the gradient is -2. If we look at this one here where it's at +1, so that's where the tangent touches the graph, we can then see that it goes across 1 and up 2. So that one's got a gradient of +2. Now, the function of the graph is x squared, but the gradient of each line doesn't follow this x squared function. So if I input 1 into x squared, I would just get 1, and if I input 2 into x squared, I'd just get 4, which is the coordinates. So that's not how we get the gradient. The way that we get the gradient is by differentiating, and that's notated by doing dy over dx. So d is delta, so that's the change in y over the change in x. It's the algebraic way of saying change in y over the change in x. D is just the same as the Greek letter delta, which just means the change. So the change in y over the change in x, and the way that we find that is by, with x squared, the function that gives us the gradient of the x squared line is 2x. And the way that you do that is by, you multiply the letter x by the power, and then you subtract 1 from the power. So we get 2x. So it's actually 2x to the power of 1, but we don't bother writing in the 1. And so we can see that if we substituted in these values, if I substituted in -2 into this function here, I would get -4. Or if I substituted 1 into this function, I would get +2. So we can see that this formula works for this graph. If I was to do one more, let's say I had x cubed, or the graph of 3x cubed. To get dy by dx, the differential, I would multiply by 3, the power. So I'd do 3 times 3, because I'm multiplying by this power. So we get 9. And then I would subtract 1 from the power. So if I had this graph, 3x cubed, I could find the gradient at any point on that cubic by inputting a number into this function, which is the differential of this. In the next video, we're going to be looking in a little bit more detail at how we would go about converting a function into its differential.